अच्छा, so atomic structure is okay. The first thing is obviously you should know okay what's a proton, neutron, electron. So I mean you have a small table, proton, neutrons, and your electrons, and the charge on the charge on a proton is +1. And remember it's the relative charge. This one is 0 and this one over here is -1. Okay, hopefully everyone knows that. Remember this is the relative charge. The actual charge is 1.6 times 10⁻⁻19 coulombs. So it's going to be -1.6 times 10⁻⁻19 coulombs. And the other one is going to be +1.6 times 10⁻⁹ coulombs. Let me just write the other one. So the other one is going to be +1.6 times 10⁻⁹ coulombs. So that's the relative charge. And then you have the relative mass as well. The relative mass is 1. So relative mass of a proton is 1. For a neutron, it's 1 as well. And for an electron, it's 1/18. 1/1836. Now remember, the relative mass is not exactly 1. It's 1. I mean, it's not exactly 1. It's 1.0 something. The actual mass of a proton, like if you look at the mass or just Google the mass of a proton, that's 1.67. So remember one thing, that when you're measuring the mass, it is always in decimals. It is always, it depends on the accuracy of the device that you're measuring. So what I have issues with is this whole number 1. It's not a whole number 1. You always remember that when you talk about the mass of a proton, it depends on the accuracy. It could be 1.0 something. So the relative mass is the mass in comparison to each other. So you can look at the mass of a proton. The mass, I mean, this is the mass of a proton. And if I Google the mass of a neutron, it's not. So the mass of the neutron is 1.67493. And this is slightly different. This is 1.6726219. And the mass of a proton, if you can have a look over here, if you go into a lot of detail, it's not exactly the same. Okay, so make sure you remember this, that when we say that the mass of a proton is 1 and the relative mass of a neutron is 1, what we mean is that they are kind of similar, but they're not exactly the same. Make sure you keep that in mind. It doesn't mean that their masses are exactly identical. It's not, because it's not. I mean, they're not identical. You can have a look. 1.6726. This is 1.67493, which is slightly different, very slightly different. Okay, so make sure you remember that. And the electron is around 9.31 into 10⁻⁻31, so it's approximately around 1836 times lighter. Okay, so just remember that these are relative masses. So this is not exactly 1. This is not exactly 1. It's and maybe in Google we might actually see the relative mass of a proton, an accurate value. Just a second, if we can find. I mean, most of the time it's just given as 1, which is not exactly true. But let's go with that. Okay, hopefully, I mean this one. I mean this one over here, it's actually 1.00773. So remember that it's not exactly 1. You can just keep that in mind. Anyways, but it's a minor point. I'll talk about why this point matters later on. Okay, but you get the idea, right? I mean, you've always studied about the relative mass. Just remember, these two are not exactly the same. Just keep that in mind. They're almost similar, but not exactly the same. I say anyway, so that means electron is really light. So one question that you often get is this thing that you got two plates, and the particles are deflecting. So there's a beam of particles, and the beam contains all the particles that you have, protons, neutrons, electrons, and they are traveling towards these plates, and these plates are charged. One of them is positively charged, the other one is negatively charged. So the protons, they move towards, I mean, firstly, the neutrons, they just continue to move forward. They will remain unaffected. Nothing would happen to them. So the neutrons just keep on moving forward. The protons, on the other hand, they get deflected. So they kind of get deflected towards the right. So that's where your protons are going. And your electrons, they get deflected more because they are lighter. So this is how the reflections would kind of look like. I mean, the electrons are going to be deflected a lot. Now, the next thing is how are particles arranged in an atom? The particles are arranged. You got a nucleus and you got electrons that are. You got a positive nucleus because it's got protons and neutrons. So the reason it's positive is because the neutron has no charge, but the proton is positive, so it's obviously positive. And the electrons are found around it. Okay, so that's obvious as well. Everyone knows this. So the electrons are present or they're scattered around the nucleus. So all these electrons, they're kind of getting attracted to the nucleus. So the nucleus is kind of pulling those electrons towards it. The electrons are like flies. They're trying to fly away, but the nucleus, positively charged, is attracting the electrons. And the force of attraction is an electrostatic force of attraction. So the positive nucleus and the electrons have an electrostatic force of attraction between them. Which is why they stay together. So it's like electrons sticking to the nucleus. Then the next thing is how do you figure out the number of protons, neutrons, and electrons in an atom? So if I give you magnesium, and the magnesium there's 12 written at the bottom and there's 24 written at the top. So hopefully everyone knows that the smaller number. Remember, the position doesn't matter in A levels. It's actually the opposite. The periodic table, the positions of these two numbers can be switched. I mean, they could be anywhere. They could be written on the right or left. I mean, it depends on the periodic table. The key is always given. So the smaller number is known as your proton number. It's also known as your atomic number. So that's known as your proton number, and also known as the atomic number. And what information does that give to you? It gives you the number of protons. It obviously gives you the number of protons, which are usually equal to the number of electrons for a neutral atom. Now, there's a lot of confusion about this bigger number. What is this bigger number? So does it even know what this is called?
Nucleon.
Okay, that's known as the nuclear number. So what is the atomic mass? Is it the same number or is it a different number?
So same 24.
It's not going to be same 24. I'll explain that. Which is why I told you, okay, So I'll come to this. So remember, nuclear number is the number of proton plus the number of neutrons. Okay. Hopefully that's clear. Okay, everyone knows that, right? Is this clear? That's the nuclear number, right? Now, when you talk about nuclear numbers are always whole numbers. Okay, they're always whole numbers. When you're counting things, it's always going to be a whole number. Like if you're counting apples in a basket, it's always going to be a whole number. It's either going to be 1 or 2 or 3 or 4. It won't be 3.1 or 3.16. I mean, you wouldn't have 3.16 apples. So when you're counting things, the things would always be whole numbers. And you don't write decimals next to them. It's going to be a round whole number with no decimals at all. But then if you open the periodic table, like if I just Google magnesium again, and magnesium, I'll just Google magnesium, it's going to give me a bunch of numbers, and over here you can see that the atomic mass is actually 24.305. So it's not actually coming out to be 24, it's actually coming out to be 24.305. So atomic mass is something else. So I'll just briefly talk about atomic mass. So remember, make sure you differentiate what a nuclear number is and what an atomic mass is. So atomic mass is, it's 12, and for magnesium it's 24 point. It's coming out to be 24.3. Now this 24.3 is known as your relative atomic mass, which is different from your nuclear number. Now, what you're doing over here is, they're kind of the same, but they're different as well. So remember, nuclear number, you're counting things. Okay, you're counting the number of protons and neutrons. So it's going to come out to be a whole number. But when you're talking about relative atomic mass, what you're doing is you're measuring the mass. The mass is never a whole number. Okay, I just told you about this. What is the mass of a proton? I told you that it's not exactly 1. If it were 1, then the number of protons and neutrons would be exactly, the mass would be exactly the same. But the thing is that the mass value is usually in decimals. It depends on the accuracy of the device. Like if I measure the mass of a proton, I mean, this thing can go on forever. Like over here, if you look at the Wikipedia page, the mass of a proton depends on the accuracy of the device. You can be more and more accurate. You can get more and more decimals. It's a never ending thing. So whenever you measure something, like if somebody tells you to measure the length of something, it all depends on accuracy. If so, measuring something and counting something, they're two different things. When you're counting something, things would always be whole numbers. But when you're measuring something, then there's no limit to the accuracy. It would just continue to go on. You're trying to measure mass. You take a weighing balance. If you try to measure your mass, sometimes it's going to give you 94 kg. If you take a more accurate device, it's going to give you 94.72 kg. So the device can be more and more accurate. So is the point clear? Is this point clear? Okay, what's the difference, right?
Yes, sir.
So the thing is that relative atomic mass is actually the mass, and it would always, it's always in decimals. And accuracy, or the number of decimals that you have, depends on the accuracy, depends on the device, on the measuring device. And the proper definition of relative atomic mass is that it's the average mass of an atom so it's the average mass of an atom compared to, you're always comparing it with something, so compared to 1/12 the mass of a carbon-12 isotope. And why is it the average mass? Do all atoms have the same mass? Would all magnesium have the same mass? The answer is magnesium has a lot of isotopes. So maybe the Wikipedia page for magnesium would tell you about its isotopes. So you can have a look. That over here, magnesium has actually 3 isotopes. It's got magnesium 24, 25, and 26. Remember, the whole number means it's the nuclear number. It's not the atomic mass. The atomic mass is always in decimals. Uh, so not sure where the. So even the mass of the magnesium 24 isotope, that's actually 23.92. So 24 was the nuclear number, but the mass is very close to 24, but it's not exactly 24. It depends how accurate the device is. So the mass is there. Hanji.
So can you like explain to me the definition again? I didn't really get it.
Which one?
Relative atomic mass.
Okay, mass, you're trying to measure the mass of the atom, right? So, ये वाला part 1/12 the mass of carbon-12.
Yes, 1/12 the mass of
अच्छा,
carbon.
उस पे तो बाद में आते हैं, ठीक है? पहले तो ये बताओ कि is this clear that the mass is always in decimals, right? I mean, is the first part clear? Okay, the mass is when you talk about, you've got two things written over here. This is magnesium 24. That means 24 is the nuclear number. Okay, that's the number of protons plus the number of neutrons, and this value is always going to be a whole number. क्योंकि आप count कर रहे हो, ठीक है? Protons और neutrons को count करोगे, that would give you a whole number value, right? Clear? But when you go and measure the mass, the mass of proton or neutron क्या होता है? Approximately 1 होता है, it's approximately 1. So if you have 24 nucleons, यानी 24 protons and neutrons, तो उसकी mass approximately 24 होगी, but the mass value is always in decimals. Its accuracy depends on the device you're measuring it with. ये बात clear? Rizwan, is this clear? Amna, Risha, is this clear?
Yes, sir.
Yes, sir.
Achha, so make sure you know this difference. Okay, make sure this is the nuclear number and this is the atomic mass, and this would always be a whole number. So they're going to cut marks. If they ask you for the nuclear number, you're going to give a whole number. If they ask you for the atomic mass, then your periodic table actually gives you the atomic mass. So that would come out to be in decimals. Anyway, so coming back to the definition of what the relative atomic mass is. The definition of relative atomic mass is that it's the average mass of an atom, first thing. So remember, magnesium is going to have many different masses. Like over here, magnesium has 3 different isotopes. All of them are magnesium. All of them are going to behave as magnesium. Like इधर यहाँ पे दिया हुआ कि if you have 100 atoms, 78 of them would be magnesium 24, 10% of them would be magnesium 25, and 11% of them would be magnesium 26. So it's the average mass. Yani all magnesium atoms, if you put them together, तो आप average लोगे. You're going to add them up and you're going to divide by 3 या जो भी ना. You'll take the average mass. ठीक है? So the average mass would come out to be, for magnesium, would come out to be around 24.3. Rizwan, is this clear? Pehli cheez.
Yes.
Okay, when we talk about relative atomic mass, we're not talking about any specific isotope. हम सारों को मिला के ना average ले रहे हैं, ठीक है? So every atom has many different isotopes. Every atom, ठीक है? Even if you pick hydrogen, that will have isotopes, ठीक है? तो उसकी abundance भी कहीं लिखी आ रही है, isotopes of hydrogen. So पता नहीं शुरू में दे देते हैं, but I'll just So if you pick any atom, तो ये यहाँ पे ना उसने दिया हुआ है कि there's hydrogen 1. Just similarly, there's hydrogen with a nuclear number of 2, and there's a hydrogen with a nuclear number of 3 as well. ठीक है, और वो जो 3 वाला ने उसने बताया अभी कि it's kind of very rare. So hydrogen has many isotopes, and similarly lots of other elements have isotopes. So it's always the average mass. Now, when you measure mass, or it's a very basic concept, but a lot of people don't actually know this. When you measure anything, whenever you try to measure, मतलब कुछ भी measure करो, ठीक है, anything, the measurement always needs a reference point. ठीक है, you need a reference. कि आप कहते हो कि what do you do कि if you measure the mass of apples, ठीक है, what do? You measure it with respect to a weight which is 1 kg, ठीक है. But you go to a shop and they have a 1 kg stone and they put it next to it, and then if the weight becomes equal to it, it's the apples would be, ठीक है, let's say this has apples in it, ठीक है, and that's your weighing balance. तो उससे आइडिया होगा कि so you always measure something with respect to a reference point. And this reference point is just arbitrary. Arbitrary का मतलब है बस किसी ने उठा के ना वैसे ही बना दिया, ठीक है. 1 kg has no definition. It's just some random person in Europe, probably in Europe. He took a stone and he said that I'm going to measure. He would probably be a king or something, ठीक है. उसने फिर अपने country के अंदर लगा दिया कि भाई ये stone है, ठीक है, I'm going to pick the stone. Everything has to be measured with respect to it. Either it's 1 kg or it's equivalent to 2 of these stones or 3 of these stones. So he set a standard. Okay, so you need a reference for that. Different countries have different standards, different references. Some countries have pounds, they use stones, okay, they use other terminologies. Metric system has kgs and grams, okay. The subcontinent had its own systems, but they are obsolete now. No one uses them. Same goes for length. Okay. What is a meter? A meter is just an arbitrary. Some random person said uh, this particular length is a meter, and everything is supposed to be measured against this. And we started measuring it against that. In the subcontinent, they actually had a different thing, which is yards. Yards were used, ठीक है, and miles are used in some other countries. So the standards are different in different countries. So the point is, whenever you measure something, you need a reference point. You need to measure it something against, like how heavy is this compared to this, right? Or how, if you're measuring length, how long is it compared to a certain reference point? So when you try to measure the mass of an atom, it's always measured against originally scientists they just found carbon. Okay, there's found carbon. Carbon is one of the most, it's charcoal basically. It's wood burnt. That's what a black powder. That's charcoal. So that was one of the most inert and most available substance. So they just started measuring the mass of all the other atoms with respect to this one. So that's about it. Okay. तो mass measure करना है तो आप इसके against measure करते हो. You take carbon atoms and you measure it कि how heavy is it compared to a carbon atom. So is this clear? ये clear है सारों को? Rizwan, is this clear?
सर ये क्लियर है, लेकिन यहाँ पे लिखा है कि कार्बन 12 का जो आइसोटोप है, आइसोटोप मतलब स्पेसिफिकली उसके साथ और भी होंगे.
हाँ, कार्बन के बहुत सारे आइसोटोप्स है ना. तो मसला ये हो जाएगा कि अब एक आइसोटोप की अगर मास 1 kg, दूसरे की मास डिफरेंट होगी ना, वो कुछ और होगी. तो यू हैव टू बी स्पेसिफिक आप किसके अगेंस्ट मेजर कर रहे हो, राइट? मतलब कार्बन आइसोटोप्स, कार्बन हैज मेनी आइसोटोप्स एज वेल, जो कि इतने अबंडेंट नहीं है, लेकिन लाइक दिस, ये देखो 15 नोन आइसोटोप्स. मतलब कार्बन 8 भी होता है, कार्बन 22 तक जाता है. दैट्स, but the most stable ones are carbon 12 and carbon 13. The ones that is the most abundant, 98.93% यहाँ पे लिखा हुआ है planet Earth के ऊपर. हो सकता है मार्स के ऊपर कोई और कार्बन एग्जिस्ट करता है, बट प्लैनेट अर्थ के ऊपर 98.93% of the carbon that you see, that's carbon 12. ठीक है, so is this clear that we are measuring the mass of all the atoms with respect to carbon 12? Anyways, that's one thing. Just don't lose marks. Okay, if he's asking for the nuclear number, that's going to be a whole number. If he's asking for the atomic mass, that's going to be in decimals. Mass is always going to be in decimals. Okay, just keep that in mind. Don't lose a mark on that. So the next thing is we'll talk about we'll just directly jump to electronic configurations now, and we'll learn how to write the electronic configurations. Now, when it comes to writing electronic configurations, what you need is when it comes to writing electronic configuration, the first thing is what is an electron? We know it's a negatively charged particle. What we know of is that if you look at a hydrogen, let's pick hydrogen, it's 1 and 1. So hydrogen के पास कितने हैं? It's got 1 proton and it's got 1 electron. मतलब hopefully सारों को पता होगा कि how do you figure out this 1 proton, 1 electron, and 1 minus 1 is the number of neutrons, and in this case it has no neutrons. ठीक है? So that's what hydrogen is. If I were to draw this, there's going to be a nucleus, or in that nucleus is going to have 1 proton. Okay, so it's going to be a positively charged proton. Now, in O levels, you studied that the electron is present in shells. So the electron is residing in shells around the atom. So it was like the negative electron is sticking to the proton. So this was the wrong model that you kind of not exactly wrong, but a very simplistic model. This was like a planetary model, which is that there's a nucleus in the middle and the electron is attracted to it and it's revolving around the nucleus, which is basically not true. The A levels model is like this. The A levels model is that the nucleus is fine. The nucleus is a very well-defined point. So we're going to bring in the nucleus. That is going to be there. But the electron actually it's not actually behaving like this. It's not a circular path that it's taking. What an electron actually is, an electron, think of the electron as a bee that's buzzing around so here's this negatively charged electron, and that negatively charged electron is like buzzing like a bee, and it's randomly moving around or sticking to the positive nucleus. So what you can think of this as, when you have a look at an atom, what you see is a positive nucleus in the center with a negative electron that's constantly buzzing around the nucleus, buzzing around the positive nucleus. Just 1 second. So this is what the electron looks like. So whenever you look at an atom, like if I just show you a picture of a hydrogen atom. So if there is hopefully there is going to be, so this is, this one is a better one. Let me just open the image in a new tab. So this is what you see. You see a positive nucleus right in the center, and you see all this negative charge that's around it. So the electron is buzzing around, so you can think of it as the negative charge of the electron that's spread around or sticking to the nucleus in the center. So the electron is not in one place. It's like a negative charge that's sticking to the nucleus, which is right in the center. So you can either think of it as this thing that the electron is buzzing around so fast that the negative charge can be seen all around it. So this is what the what an electron looks like in reality. And no one has actually seen how the electron moves. All that we know is, and this is how you're going to treat an electron. No one has ever seen an electron or taken a picture of an electron. All they know is that it's a negative charge. And the negative charge is it's completely surrounding the nucleus or sticking to the nucleus. We do know that there's only one electron. Why? Because it has a very specific mass. So think of it as one way to think of it is like a fly that's just moving around very, very quickly. ठीक है, जैसा वो मिठाई के ऊपर ना मक्खियां आ रही होती है ना, तो it's moving very, very quickly, and it's all over the place. And it's completely surrounding the nucleus. The other way to think of this is a negative charge that's spread around the nucleus or sticking to the nucleus. So is this idea clear? Okay, from now on, we're not going to talk about the electron as a particle that's moving in a certain random way, because no one has ever seen an electron. No one knows where it's going. All they've seen is this thing. Kangi, my picture. All they've seen is this thing, that there's a nucleus and there's this negative charge that's all around it. ठीक है?
सर
हाँ जी.
सर अगर ये एक इलेक्ट्रॉन है तो इतनी ज्यादा स्पेस कैसे ऑक्यूपाई कर रहा है, सिंस इसकी वेलोसिटी भी लाइक पता चल जाती है, तो क्यों इतनी ज्यादा स्पेस ऑक्यूपाई कर
नहीं, उसकी वेलोसिटी किधर पता लगती है? इलेक्ट्रॉन का आप the only thing you can actually measure for an electron is कि उसका negative charge. I mean, you're pretty sure because you've actually measured the negative charge. So we know that it's whatever the negative charge is, it's 1.6 times 10 power minus 19 coulombs, right? We know the mass, it's got a very specific mass, जो कि 9.31, I think, into 10 power minus 31 kg है. अच्छा, इन दोनों को देख के ना हमें पता लग जाता है कि हमारे पास कितने इलेक्ट्रॉन्स है. लाइक इफ द चार्ज इज डबल, दैट मींस वी हैव गॉट 2 इलेक्ट्रॉन्स. अच्छा, सो स्पेस किस तरह ज्यादा ऑक्यूपाई कर रहा है? स्पेस है कि आप पहली चीज तो याद रखो कि किसी ने देखा नहीं है कि इलेक्ट्रॉन कैसा है. ठीक है, तो हम इसको ना कुछ भी अज्यूम कर सकते हैं. वी कैन अज्यूम इट एज लाइक अ जेली दैट्स जैसा जेली नहीं होती नेगेटिव चार्ज की, दैट्स सराउंडिंग द पॉजिटिव न्यूक्लियस. मतलब उसको जो मर्जी आप सोचना चाहो वो सोच लो. ठीक है, but the negative charge is spread around the nucleus. You can think of it as a wave. जैसा wave नहीं होती, मेरी आवाज जो है वो let's say मेरे रूम में ना हर जगह फैली हुई है, तो you can think of it as a wave that's sticking. जैसा वो waves होती है ना सी के अंदर, तो वो सी से बाहर तो नहीं आती है. अगर एक टैंक है, वाटर टैंक है, तो उससे बाहर नहीं आ रही होती ना वेव्स, उसके अंदर ही वेव्स ट्रैवल कर रही होती है. तो यू कैन थिंक ऑफ इट एज अ वेव ऑफ नेगेटिव चार्ज that's sticking to the nucleus. ठीक है, तो or you can think of it as a fly that's moving so fast कि एक outside observer जो कि हम है, हमें ऐसा लगता है कि when we think of this image, the electron might be moving so fast and buzzing around like a fly so fast कि to an outside observer it appears कि वो हर जगह है. जिस तरह पंखा चल रहा होता है ना, like if you have a moving fan, तो मूविंग फैन में कभी आपको वो ब्लेड्स नजर आते हैं? नहीं आते ना. व्हाट यू सी इज, मतलब फैन में इसलिए नजर आ रहा है when it's moving around, you just see this blurred version, blurred smudge. ठीक है, clear is Rizwan, is this clear?
यस सर.
ठीक है, या फिर आप इसको ना एक वो सोच लो कि ये जो नेगेटिव चार्ज है ना, इट्स लाइक अ क्लाउड जो उसके साथ आके ना पॉजिटिव के साथ स्टिक हुआ है. ठीक है, जैसे हम आसमान में बादल नहीं जा रहे, तो देयर इज अ नेगेटिव चार्ज क्लाउड with many smaller negative particles, and they're all sticking to the nucleus. Okay? So whatever way you want to visualize it, think of it as a fly, think of it as a wave that's attracted to the positive nucleus. इसको wave particle duality कहते हैं, which is कि sometimes the electron behaves as a particle, and particle का behavior बड़ा specific होता है. Particle is located in one very specific place, but a wave is not located in one specific place. Like my voice can be in many places at the same time. So दुनिया में ना दो टाइप्स के बिहेवियर्स होते हैं. वन इज पार्टिकल एंड द अदर वन इज wave. So an electron is kind of like on the boundary. It's like you don't know, okay, because no one has ever actually seen an electron. All we've seen is this thing. Okay, there's a negative charge that's sticking to this nucleus in the center. Okay, moving on. That's what an electron is going to be look like. So next time when we look at an electron, we're going to describe it by its orbital. This is known as the orbital of an electron. As an orbital is derived from an orbit. Because pehle we thought that the electron, like the old model was, we thought that the electron was orbiting the nucleus, just like a planet is orbiting a nucleus. And then this picture came along. Then we realized the electron is not actually orbiting. It's just a negative charge that's all around the nucleus. Okay? So orbital, इसलिए वो orbit type है. Orbital means something like an orbit. Okay? So an orbital is a region or a region of space around the nucleus where there is a high probability of finding the electron. So where there is a high probability of finding this negative charge, of finding this electron. ठीक है, so if I go back to the picture over here, so वो negative charge की probability inside of it, that's almost zero. I mean, you don't have negative charge over here. So orbital is this circular region. कि भी negative charge कहाँ पे मिलेगा? It's going to be found somewhere in this area. The electron and its negative charge is found in this area. So an orbital is the place where the negative charge is located. So in this case, I have a spherical orbital, which is nucleus there's a spherical region where there's a very high probability of finding the electron. The negative charge is located around the nucleus in the spherical region. On the is either zero at here, there's zero probability of finding the negative charge in this area over here, but a very high probability of finding the negative charge in this spherical region over here. Is this clear what an orbital is?
Yes, sir.
ठीक है, और इसमें हम quickly कर लेते हैं कि this is known as an S orbital. Okay, that's your S orbital. S orbitals are spherical. Okay, and you have other types of orbitals. Sometimes what happens is, okay, there's other types of orbitals. Like if you have a nucleus in the center, sometimes what happens is that the electron's negative charge is located in two lobes around the nucleus. So the negative charge is spread over here in these spaces over here. There's a lot of negative charge over here, negative charge over here. So the electron is located, its negative charge is found over here or over here. And there's absolutely zero probability of finding the negative charge in these areas over here. That's known as a p orbital. And let me show you what a p orbital looks like. There must be an image of a p orbital. Just a second. If there's an actual, I mean, of a real p orbital. So, नहीं. This one. So this one, yep, this one. So let's open this new tab. So let's just focus on this one over here. So sometimes what will happen is that the nucleus is over here and the negative charge of the electron can be found on two sides. or in two lobes. You can either find the negative charge over here or the negative charge over here. Here's another type of p orbital. Again, it's two sides. The negative charge, you don't see the negative charge over here or over here. The nucleus is right in the center. Negative charge is over here or on this side. Just like this image, the negative charge is over here and over here, not present over here on these two sides. So we'll continue with the orbitals. Is this clear? You have orbitals, right? Is the concept of orbitals clear?
Yes, sir.
So कल कंटिन्यू करते हैं फिर इधर से ठीक है. For this I'll just 1 second. Sure. चलिए I'll post it in the group. ठीक है. Okay, Allah Hafiz.